In this presentation, we're going to look at probability functions such as the probability density function and the cumulative distribution function, and a couple of examples based on those. So here is our question there. Suppose that x is a random variable with probability density function given as follows: a plus bx squared. This is over the range 0 to 2, where a and b are constants. And importantly, we're told that the mean value of x is 1.5. That's actually quite important. So first off, what we have to do is find a and b. Then what we have to do is determine the cumulative distribution function. And then finally, what we have to do is compute the variance of x. So let's get cracking at that. Compute the coefficients a and b. Well, there's two important pieces of information we're given. The first is it's not actually given, it's just sort of inferred in the question, particularly the fact that the limits are 0 and 2. Total area under the curve defined by the probability density function must be equal to 1. Secondly, we're given this clearer piece of information that the expected value mu, or e of x, is 1.5. So we're actually going to be able to find a and b from these two clues. So let's look at the first one here. What we have to do is integrate this. So ax, I'm just going to integrate this term here. That's equal to ax plus bx cubed divided by 3. Now let's apply the limits 2 and 0. And that's equal to 2a plus x cubed is 8. So we have 8 over 3 b. That's the first. That's for x equals 2. When x equals 0, we just have 0 and 0. So the first important conclusion we can make is 2a plus 8 over 3b. That's equal to 1. That's the important thing here. That is equal to 1. That's our key conclusion from this remark, that we're able to come up with an expression for a and b and it's equal to 1. We're going to do something similar now for the other remark, that the first off, this is essentially the definition of how to compute the mean, x times the probability distribution function, and then you integrate that. So ax plus bx cubed, what we do is integrate that, and we get ax squared plus bx to the 4 all over 4. And apply the limits again, 2 and 0. This time we're just going to concentrate on x equal 2. We know that the x equals 0 just gives us zeros. So we have, sorry, that's a square there. So what we have then is, that's divided by 2 actually, sorry. So what we have is x squared is 4, divide that by 2. What we end up with is 2a. X to the power of 4 is 16, divide that by 4, we get 4. So plus 4b, and that is equal to 1.5. So that's the second conclusion we make. Now we have two simultaneous equations here. So 2a plus 8b over 3, that's equal to 1. And 2a plus 4b equals 1.5. I'm just going to re-express this second expression here. 12b over 3, that's just 4b in other words, equal to 1.5. What I'm going to do is subtract the first expression. 8 over 3b, that's equal to 1. And what I'm going to do is subtract, find the difference here. So 4 over 3b equals 0.5. Now if we were just to sort of rework this equation here, we'd find that b is equal to 3/8. Now subbing b equal to 3/8, subbing that back into one of these other expressions, for example this one here, we would find necessarily that a must be equal to 0. Okay, I'll just sort of I'll let you check that for yourselves. But we have a and b. A is equal to 0, and b is equal to 3/8. So that's the first part of our exercise done. Let's move on. So find the cumulative distribution function here. So this is the definition of it here, more or less. All we do is integrate the probability density function. Now I'm just going to sort of place in the probability density function here, a plus bx squared. We can sort of disregard a from now on because simply it is 0. So essentially all we have to do is integrate bx squared dx. Actually bx is 3/8. Oops. So what we have here is 3/8 times x cubed over 3. The 3's cancel out. So the answer we're left with is x cubed over 8. So that's the cumulative distribution function there. X cubed over 8. Finally, what we're going to do is compute the variance. There, I have it done there again. So I'll just move on. So what we have to do now is compute the variance here. So there's a couple of ways that we can express the formula. I'm just going to use this one down here. So what we have to do is x squared times the PDF, the probability density function, minus mu squared. So after the fact we will subtract mu squared. So what I'm going to do here is I put in the probability density function here again. I'm going to disregard a because we know that's 0. All I have to do really is integrate bx to the 4 with the limits 0 and 2. After the fact, I subtract the number 1.5 squared. So let's look at that now. So integrate from 2 to 0, 3/8 times x to the 4 dx minus 1.5 squared. So let's just concentrate on the integral here. That is equal to 3/8 times x squared, x to the 5 over 5 from 2 to 0 minus 1.5 squared. So let's just look at this now. That's 32 over 5 by 3/8 minus 1.5. So that's 2.25. And just working it out with a calculator, what we get is 96 over 40 minus 2.25, and that is equal to 2.4 minus 2.25, and that gives us an answer of 0.15. So the variance here is 0.15. And that ends our presentation.